4.0.0 Hazards and Safety Requirements. After doing this module, you should be able to identify safety hazards associated with ladders, scaffolds, and lift equipment, describe confined space entry procedures, explain safety procedures used with dangerous materials. Your instructor will have you describe safety requirements for an instructor-supplied task, such as replacing the lights in your classroom, discuss the work to be performed and the hazards involved. If a ladder is required, perform a visual inspection of the ladder and set it up properly. Ensure that local emergency telephone numbers are either posted or known by you and all the other employees. Plan an escape route from the location in the event of an accident. There are many hazards on a job site. These include fall hazards, equipment hazards, chemical hazards, and tool hazards. Best prevention is safety awareness. If an accident occurs, know where the first aid kit is. Always follow company procedures for reporting it. Emergency first aid telephone numbers must be available to everyone on the site. Refer to CFR 1910.151 as well as CFR 1926.23 and 1926.50 for specific requirements. 4.1.0 Ladders, scaffolds, and lift equipment. About half of the injuries that result from contact with energized components involve ladders and scaffolds. In addition to electrical injuries, a person receives a shock, sometimes has an involuntary movement. This can result in a fall from ladder or elevated surface. 4.1.1 Ladders. Many job site accidents involve the misuse of ladders. According to the American Ladder Institute, thousands of U.S. workers are hospitalized each year while working on ladders. While most of the injuries don't result in death, recent data from the Bureau of Labor Statistics indicates that approximately 160 people die each year while using ladders. Ladders are so hazardous that many contractors have a ladder last policy, meaning they prefer to use personnel lifts, construct scaffolding, or move the work to ground level when possible. This is because they don't want employees exposed to the hazards of working from a ladder. To prevent serious injury or even death, adhere to the following general rules every time you use a ladder. Select the correct ladder for the job. Ensure you select the right type of ladder for the job, either a straight ladder, extension ladder, step ladder, platform. You must also choose the correct material, fiberglass versus aluminum. I don't know that they use aluminum ladders on jobs anymore. I think they've been done away with. Basically, all ladders are going to be fiberglass or wood, and I don't think there are a lot of jobs that don't want wood anymore. So fiberglass ladders really are what you're going to see. Inspect the ladder before use. Look for loose or missing rungs, cleats, bolts, or screws. Also, check for cracked, bent, broken, or badly worn rungs, cleats, or side rails. Refer to Figure 23 for an example of rail damage on a fiberglass ladder. It's sun-baked and it's been abused. It might have been dropped, but the fiberglass is starting to separate where it was adhered together to form the rail. So this ladder should not be used anymore. It should be cut up and thrown away, disposed of. Clear debris from around the base of the ladder. This is important so you do not step or trip over it when you descend. Do not use a ladder that is in poor condition. Report it and tag it for repair or disposal. Never modify a ladder. Ladders should not be modified by cutting them or weakening the parts. Set up ladders in a location that is safe from people. Do not set up a ladder where people may walk underneath or you could be walked into by others. Do not set up ladders in doorways or walkways. If it's necessary to set up a ladder in such a location, protect the ladder with barriers and install signs that alert others to the hazard. Do not increase a ladder's reach. Do not put a mechanical lift or stand it on a box, barrels, or anything other than the flat, solid surface. Check your shoes for grease, oil, or mud before climbing a ladder. These materials could make you slip. Always face the ladder and maintain 3-point contact with the ladder. Always have both feet and one hand on the ladder or both hands and 1 foot. Never lean out from the ladder. Keep your belt buckle centered between the rails. If something's out of reach, get down and move the ladder. Never pull from a ladder. If you pull with one hand while holding on with the other, it'll cause you to shift your balance. This may result in a fall. Only pull with both feet on a solid platform. Warning: when performing electrical work, always use a ladder made of non-conductive material to reduce the risk of electrical shock. This is highlighted. It says always place a straight ladder at the proper angle. And here's your highlight. It says the horizontal distance from the ladder feet to the base of the wall should be about 1/4 the working height of the ladder. So the working height is how far off the ground the ladder touches the platform. So if this is 16 feet, then the distance out from the base of the building or the wall to the rungs, to the rails, should be 4 feet. It should be 1/4 of that working distance. And if you're using a ladder to gain access to a landing above, you need a minimum of 3 feet above the landing you're going to be stepping off to. That gives you something to hang on to when you're stepping onto the platform, onto the landing. Secure straight ladders to prevent slipping. Use ladder shoes or hooks at the top and bottom. You can also secure a board to the floor against the ladder feet. For short duration jobs, someone can just hold the bottom of the straight ladder. Make sure the side rails are the proper distance above the top support. Side rails should extend above the top support point by at least 36 inches, 3 feet. This gives stability as well as a handhold when stepping around the ladder. Always use 2 people to safely extend and raise an extension ladder. Extend the ladder only after raising it up to the right position. Never carry an extended ladder. Never use 2 ladders spliced together. 2 ladders should never be combined to make a longer ladder. This does not provide a stable base. Ladders should not be painted. Paint can hide cracks and defects. Here's the fireman's rule. It says to verify the proper angle of a straight ladder, you must follow the fireman's rules. Place your feet against the side rails, stand straight up, extend your arms at right angles to your body directly in front of you. If you can grab the side rails with both hands, the ladder's at the correct angle. So here's the fireman rule. When you're standing at the base of the ladder, if you extend your arms straight out, you should be able to grab the side rail of the ladder. It's approximately a 72-degree angle, but we don't carry a compass with us, so you don't know if it's 72 degrees or not. Always open the step ladder completely by locking the spreaders to avoid the ladder accidentally collapsing. Use a step ladder that is high enough for the job. This is important so that you do not have to reach. It's a good idea to have someone hold the ladder if it's more than 10 feet high. Never use a step ladder as a straight ladder. Don't lean it up against the wall. It's not what it's meant for. Never stand on or straddle the top 2 rungs of a step ladder. Do not use ladders as shelves. Warning: do not leave tools or materials on a step ladder. They might fall off on someone else or cause someone climbing the ladder to trip and fall. Sometimes you'll need to move or remove protective items to complete a task with a ladder. Always wear the correct protection. Replace what you moved or removed before leaving the area. 4.1.2 Scaffolds. Working on scaffolds, you must always be safe and alert to hazards. Scaffolds are covered in Code of Federal Regulation 1926, Subpart L. So here's scaffolds completely surrounding this building so that workers can work on it. They're either putting stucco on the outside, or they're going to paint it. For some reason, they've got this building completely wrapped in scaffolds. Use only scaffolding and planking materials made and marked for their specific use. When working on scaffolds, follow the established specific requirements set out by OSHA for the use of fall protection. When appropriate, wear an approved harness with lanyard anchored to the structure. Keep scaffold platforms clear of unnecessary materials or scrap. These can be deadly tripping hazards for falling objects. note these rules represent a compilation of more stringent requirements of both CFR 1910 for general construction or general industry and CFR 1926 for construction. Following are some of the basic OSHA rules for working safely on scaffolds. Scaffolds must be erected on sound, rigid footing. Scaffolds must be erected straight with no bent or deformed pieces. Guardrails and toe boards must be installed. There must be a screen. Be sure the platform is correctly installed. Here's a highlight. It says each end of the platform must extend over the center line by at least 6 inches, but no more than 12 inches. So that's the planks. The planks that you put on the scaffold have to overlap the ends of the scaffold by at least 6 inches, no more than 12 inches. Use an attached ladder access when needed. Train all employees who erect or dismantle scaffolds, wear fall protection, work platforms must be completely decked, use trash containers to keep debris from falling, and inspect scaffolds for visible defects. I'm not going to read the case history. 4.1.3 Lift equipment. On the job, you may work on lifts, hoists, or cranes. Following safety rules are for those who work near overhead equipment but are not directly involved with its operation. You must be trained and or properly licensed to operate any type of forklift. Stay alert. Always pay attention to the warning signs from operators. Never stand on or walk under a load. This is true if it's moving or stationary. Always warn others of moving or approaching overhead loads. Never distract signal personnel or operators of overhead equipment. Obey all warning signs. Do not use equipment that you're not qualified to operate. Ensure barricades are in place in areas where places where persons can become trapped or pinched. Cranes must have barricades placed around them to warn any workers. Secure hoists. Hoists must be secured to prevent them from being pulled down. Never overload a hoist, lift, or crane. Always follow lift ratings. Inspect cranes, lifts, and hoists daily. Never lift a person using a crane, hoist, or material lift. Never use equipment improperly. For example, never rig a lift to hoist a load. Train people who will be using and installing rigging. It's extremely easy for a load to fall out of incorrectly rigged lifts. Use rigging equipment within their limits. Personnel hoists require gates. Use gates on every landing that can be opened from the hoist side. This ensures that they're not opened onto a fall hazard. 4.2.0 Confined Space Entry Procedure. If you remember, a confined space is a space that is not meant for continued human habitation. It usually only has one entry or egress, and it's no wider than 30 inches in any direction, the opening, that is. As an electrician, there may be times when you need to work in a confined space. Manholes are a confined space. CFR 1926 subpart AA about confined spaces in construction. If you're in a confined space, you need to be aware of some special safety considerations. For details on working in manholes and vaults, refer to CFR 1926.1200 through 1213. General guidelines. Figure 27 is an example of a confined space where an electrician might work. Note the characteristics of the confined space identified in the image. So there's a ladder for entry and egress. This is a man lift, so that if the worker goes down in the manhole and for some reason he passes out, you don't want someone going in after him. If there's methane gas or if there's something that knocked that worker unconscious, you don't want another worker climbing in on top of him and passing out. So he has a safety harness on with the D-ring between his shoulder blades, and they will tie this man lift to him. If something happens and he becomes unresponsive, the man above will turn the crank lever and he'll raise him up out of the hole. Okay. And there's barricades to keep people from walking into the manhole when it's open. This isn't on a platform. This is ground level. They just cut this away so you could see the inside the manhole. But this is the earth, and this extends. It continues in all directions. So I don't want you to think that he's up on top of something that he could fall off. The manhole is probably at ground level. Here's the ladder going into the manhole. This is supplying fresh air to the employee. So it's blowing fresh air down here. The cabinet is vented. Uh, let's see. Let's see what they say here. They show, okay, potential for electrical or explosive hazards, potential for entrapment or engulfment. That's inside of here. Potential for accumulating dangerous atmospheres. That's why they're supplying fresh air down here so that you're not breathing the same air. Not intended for human occupancy, and it's restricted entry and exit. Very good. Examples of confined space include, but are not limited to, manholes, boilers, tanks, tunnels, hoppers, bins, sewers, vats, pipelines, vaults, air ducts, vessels, silos. If there's a storage silo on a farm, that's a restricted, that's a confined space. Entry into a confined space occurs when any part of the body crosses the plane of entry. No one should enter a confined space unless they have been trained in confined space entry procedures. Other requirements for confined spaces include the following. All hazards must be eliminated or controlled before a confined space entry is made. The air quality in the confined space must be monitored. All appropriate personal protective equipment shall be worn at all times during confined space entry and work. Ladders used for entry must be secured. Use a rescue retrieval system when entering confined spaces and while working in permit required confined spaces. Barricade the area outside the confined space. Job site supervisors must issue and sign entry permits. These permits must be kept at the confined space while conducting work. At the end of the shift, put the entry permit into the job journal and keep them for 1 year. So you have to keep that confined space entry permit for 1 year. Very good. 4.2.2 Confined Space Hazard Review. The hazard risk assessment should include the following conditions: the past and current uses of the confined space, the physical characteristics of the space, including size, shape, air circulation, etc., proximity of the space to other hazards, existing or potential hazards in the confined space, including atmospheric conditions, oxygen level, flammable explosive levels, and/or toxic levels, presence of or potential for liquids, presence of or potential for particulates, or potential for engulfment, potential for mechanical, electrical hazards in the confined space, including work to be done. That potential for engulfment is usually if it's an excavation. The manholes usually have concrete sides, so there's not much of a risk of engulfment. Once the hazard risk assessment is completed, the supervisor, in consultation with the project manager and/or safety manager, shall classify the confined space as one of two of the following: either a non-permit confined space or a permit-required confined space. Permit-required confined spaces must be posted. Once the confined space has been properly classified, the appropriate entry and work procedures must be followed. So there are confined spaces that are not entry permit. They've been there, they've been tested several times over a year, and there's never been the existence of any kind of explosives or methane or carbon dioxide or carbon monoxide. So it apparently is having an adequate change of environmental air that keeps the system free from hazards of that sort. So you can put a ladder in, your foreman can tell you you've got to go in there and do some work, and you can go in without having to have an entry permit. You still need to wear the proper PPE, you still need a recovery system, you still need a man up top keeping an eye on you. You still need to monitor the atmosphere in case something happens while you're in there and the atmosphere becomes harmful. 4.3.0 Dangerous Materials. CFR 1910.1200 lists hazard communication requirements for dangerous materials. It's important to prepare in case an accident occurs on the job site. First aid training is the best insurance you or your fellow workers can receive. Remember, anything other than drinking water will have an SDS, a safety data sheet. Even Vaseline, petroleum jelly, oils, any kind of acids or caustics, anything on the job site will have one of these SDSs. So make sure you know where to find first aid at your job site. Also make sure you know the accident reporting procedure. Each job site should have a first aid manual or booklet that provides easy to find emergency treatment procedures for various injuries. Additionally, make emergency first aid telephone numbers available to everyone on the job site. 4.3.1 Solvents. The solvents used by electricians may give off vapors. These vapors can be toxic enough to make people ill or even cause permanent injury. Many solvents are skin and eye irritants. Solvents can also be poisonous when they are swallowed or absorbed through the skin. There are specific procedures and methods for using, storing, and disposing of solvents and chemicals. This is a highlight. You can find these procedures in the safety data sheets available at your facility. Again, any material other than water on a job site must be accompanied with a safety data sheet. An SDS is required for all materials that can be hazardous to personnel or equipment. These sheets contain information on the material, such as the manufacturer and the chemical makeup. Keep as much information as possible on the hazardous material. This can prevent a dangerous situation. If a dangerous event does occur, the information can be used to correct the problem. So here's an example of a safety data sheet. It gives you the product name, product catalog, and I'm sure it's going to tell us the manufacturer. Here's Greenlee Tools Incorporated. There's a 1-800 number you can call in case of emergency. And it says you can call 911 or local emergency numbers. PPE used with solvents. Wear a chemical face shield with chemical goggles in case of splashing. Use chemical cartridge respirators in situations where a paper mask does not supply enough protection. Wear gloves that are appropriate for the type of chemical in use. Wear a chemical apron, again, for splashing. If you're moving a chemical from one container to another, there could be splashing. Warning, paper mask filters may stop larger dust particles, but they do not stop dangerous vapors from entering your lungs. Always use chemical cartridge respirators in situations where you may come in contact with hazardous vapors. In areas where ventilation is also a problem, use a self-contained breathing apparatus. If possible, avoid hazards that can cause respiratory difficulties. Off-shift work, ventilation, and flexible work schedules can help you avoid situations where you may be forced to work in areas with poor air quality. Here's a warning. It says, always read and follow the directions found on the chemical containers. Avoid chemical exposure by following these instructions. Remember that everyone reacts differently to chemicals. If you're sensitive to a particular chemical, leave the area at the first sign of an allergic reaction. If necessary, seek medical attention. So it says there are 3 categories of air purifying respirators. The particulate removing respirators, mechanical filter, protects the wearer from inhaling particulate matter in the atmosphere. They protect against a single type of particulate such as pneumoconiosis producing dust, nuisance dust, toxic dust, metal fumes, or mist. They can also protect against various combinations of these particulates. Gas and vapor removing respirators, chemical filter. They protect the wearer from inhaling gases or vapors in the atmosphere. Examples of these gas masks, chemical cartridge respirators, non-emergency gas respirators, and self-rescue respirators. They protect against a single gas such as chlorine, a single type of gas such as acid gases, or a combination of these gases, such as acid gases and organic vapors. Combination of particulate removing and gas and vapor removing respirators. In some cases, air purifying respirators are a combination of particulate removing and gas and vapor removing respirators. If you're required to use a respirator protective device, remember that a physician must evaluate you to ensure that you're physically fit to use a respirator. They'll send you to a medical facility, or they might have an on-site facility with doctors and nurses, and they will actually have you do exercises breathing into a tube. You have to sustain it for 30 seconds or a minute, and if you don't have the capacity in your lungs to move a ball in a tube as you exhale or inhale, you can't wear a respirator at work. Not a rescue respirator. I mean, you can't be assigned to work that needs you to wear a respirator while you're in that area. Warning, do not use respirators unless you've been fitted for it and thoroughly understand its use. As with all safety rules, follow your employer's respiratory program and policies. 4.3.3, batteries. Working around wet cell batteries can be dangerous. It's important to take proper precautions because some batteries can give off hydrogen gas as a byproduct. The hydrogen mixes with the air. In some cases, it can be explosive. Lithium-ion batteries pose other hazards. They have a much higher density of energy compared to older battery types. When coupled with a lithium-ion battery's flammable electrolyte mixture, all it may take is a short circuit, an overcharge, or high temperature to result in a phenomenon known as thermal runaway. Thermal runaway is a chain reaction within the battery that's very difficult to stop once it begins. When this reaction occurs, it can escalate within seconds to produce extreme temperatures and fires that are difficult to extinguish. I used to watch a show, what was the name of it? Top Gear. British show with these guys who like to drive expensive and fast cars. They talk all about cars. In one of the episodes, one of the three was driving an electric race car, and it was relatively new because electric race cars are a relatively new idea. But electric race cars are very fast. They have very fast acceleration, and they can go top end. Very well, long story short, he went off the track and ended up over in the bushes. He didn't get seriously injured, but he did get injured. But about 30 seconds after they got him out of the car, and they were all laughing about it, the car burst into flames, and they couldn't put it out. It burned until it burned away all of the fuel in the batteries. It was an electric fire and a metallic fire, and there was no putting it out. They all just said, well, let's just stand back and let this thing burn itself out. It's a very hot flame. So batteries are very dangerous. Don't think, being around D batteries and C batteries, batteries aren't anything. Yeah, they are. When you put batteries together in series, you add the voltage. So you can take a 12-volt battery, you can add, 10 of them in series, and you've got 120 volts. If you add 20 of them, you got 240 volts. You can get 360 volts. You can just keep increasing that voltage to a point where, they're going to do a lot of damage if there's a short circuit. Anyway, all right. So if you're in an electric car and you're wrecked, get away from it quickly. Don't let it burst into flames. 4.3.4, acids. Battery acid is a substance that can eat away human skin and many other materials. Personal protective equipment for battery work typically includes chemical aprons, sleeves, gloves, face shield, and goggles. These prevent acid from contacting the skin and the eyes. Follow your site procedures for handling spills of these materials. In addition, know the location of your first aid kit. Caution: if you come in contact with battery acid, flush the affected area with water and report it immediately to your supervisor. I don't know, I'm not trying to make fun of anyone, but anytime they tell you to flush your eyes, they always say 10 minutes. Like that's the minimum amount of time that you are going to flush your eyes. If they say, oh, if you get it in your eyes, flush with cold water for 10 minutes. It's always 10 minutes. I don't know why. I don't know if they determined that in 10 minutes, the benefit that you can get from flushing your eyes with water, you've gotten the maximum amount of benefit. And 12 minutes isn't going to do any better, and 15 minutes isn't going to do any better. They always say 10 minutes. Flush your eyes for at least 10 minutes. So if anything ever happens and you get something in your face, run over to an eye wash station and flush your eyes for at least 10 minutes and call for help. Let's see, PCBs and vapor lamps. Polychlorinated biphenyls are chemicals marked under various trade names as a liquid insulator or cooler of older transformers. In addition to being used in older transformers, PCBs are often found in some large capacitors. Occasionally, they even show up in small ballast transformers used in street lighting and ordinary fluorescent light fixtures. Disposal of PCBs is regulated by the Environmental Protection Agency and must be done through a regulated disposal company. Use extreme caution and follow your facility procedures when working with PCBs. Warning: do not come into contact with PCBs. They present a variety of serious health risks, including lung damage and cancer. 4.3.6 Lead Safety. In 2010, the EPA enacted the Renovation, Repair, and Painting Rule. The standard protects young children from living or spending time in buildings containing lead-based paint. It requires lead-safe certification and work practices. These work practices must be followed during renovation work on all homes or other child occupancy facilities built before 1978. The rule applies when disturbing more than 6 square feet per room of an interior painted surface or more than 20 square feet of an exterior painted surface. The rules applied to housing and urban development projects involving only 2 square feet of interior lead-based paint or more than 20 feet of exterior lead-based paint, or 10% of the total surface area on an interior or exterior painted component that contains lead-based paint. You can pick up a lead tester at Home Depot. If you suspect that your house might have lead paint, I suggest getting one of these and trying to chip the paint down to the bare either wood or the wall surface. Try to get to the original paint of that house, and then put it in the tester with a couple of drops of some kind of liquid. I don't know what the liquid is, but if it turns pinkish or red, there's the presence of lead in that paint. The RRP rule contains the following basic requirements. Each job site must have at least one RRP certified renovator. Certification involves lead-safe work training by an EPA accredited training provider. Certification of the contracting firm or agency must occur in addition to individual certification, and contractors must give the client a copy of the Renovate Right pamphlet available for download at www.epa.gov. 4.3.7 Silica Safety. Silica dust is created when cutting or drilling in concrete, masonry, and rock. Prolonged exposure to silica dust can cause lung cancer, silicosis, chronic obstructive pulmonary disease, and kidney disease. So refer to CFR 1926.1153 and CFR 1910.1053. According to OSHA, exposure to respirable silica dust affects approximately 2 million construction workers on the job each year. I've seen guys cutting concrete with a concrete saw, not wearing a face mask of any kind. And I think, dude, why are you doing this to yourself if your boss won't get you a dust particle mask? go to Home Depot and buy your own, or better yet, quit. You know, don't do something that's going to affect your health over the long term just because your boss says, well, we've never used them. I don't think you need one. Well, you're not the one cutting the concrete. I am. So I want a mask. And you can even cite OSHA if you want. You just say, okay, well, if you don't think it's a problem, I think I'm going to give OSHA a call. Get them out here. See how quickly he changes his mind. And if he fires you because you said you were going to call OSHA, now you've got a lawsuit. So, all right. OSHA introduced the silica rule to combat the negative health effects of occupational exposure to silica. This rule reduces the permissible exposure limit for respirable crystalline silica. It lowers it to 50 micrograms per cubic meter of air, averaged over an 8-hour shift. It also requires employers to use the following controls to limit the workers' exposure. Implement engineering controls, for example, tools equipped with shrouds or dust collection systems and tools equipped with integrated water delivery systems help reduce worker contact to the permissible exposure level. So you can do wet work. You just have a trickle of water on the blade of that saw and it turns that silica dust into liquid concrete, and it's no longer airborne, so you're not going to inhale it. Provide respirators when engineering controls cannot adequately limit the exposure. Limit workers' access to high exposure areas. Develop a written exposure control plan. Offer medical exams to monitor highly exposed workers and supply information about their lung health. Train workers on silica risks and how to limit exposures. And then here is OSHA exposure control for silica, one of two. I'm not going to go over this chart. You can look at that in your book. And here's 7B, OSHA exposure controls of silica, 2 of 2. So again, this is straight out of OSHA. 4.0.0 section review. Maintaining 3-point contact on a ladder means that at least 3 of the 4 rail points, no. You may reach as far, no. You must either have both feet and one hand on the ladder or both hands and one foot. C. 3 points. 3 of your points. 2 feet, 1 hand, 2 hands, 1 foot. Which of the following is considered a confined space? Narrow alleyway between buildings? No. A hopper? Yes. Shallow trench? A horse pen? A hopper. Fluorescent light fixtures may contain PCBs. So, this concludes 26102, Safety for Electricians. If you got anything out of the video, please consider liking and subscribing. Hit that thumbs up. I appreciate it, and I'll see you on the next video. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.